So in question one, we are giving, or example one, we are given that the president's approval rating is 56%. So that means, in this case, we know the population proportion is 56% or 0.56. We're also going to look at samples of size 100. So that means that my sample size, or N, is 100. So you're basically asked two things here. The first thing you're asked for is the mean of the p-hat values. The mean of any statistic, if it's a good statistic, is always equal to the parameter it's estimating. P-hat estimates the value for P, which means the mean of the p-hats is equal to P. So in this case, this should be an easy question. The mean of the p-hats is equal to P, which means that the mean of the p-hats is simply just 0.56. That's all you have to do. The mean of any statistic is always equal to the parameter it's estimating. The standard deviation, you have to do a little more work here. The standard deviation of p-hat is equal to the square root of p 1 minus p over n. So we plug in what we know. P is 0.56, 1 minus 0.56, n is 100. So you don't have to show every step, but if you do, 0.56 times 1 minus 0.56 is 0.2464 over 100, which is the square root of 0.002464. And if you plug that in your calculator and take that square root, you will get 0.0496. So the standard deviation for all p-hat values from samples of size 100 is 0.0496. So notice in this case, that the mean is not affected by the sample size. However, the variability is, and that's always the case with any statistic. The variability in a statistic is affected by the sample size, because as you increase the sample size, you get less variability, or basically a more accurate estimate. That variability, as you will see in this chapter, is actually a measure of how much error to expect whenever we go to estimate a parameter based on a statistic.